Law of sines. Notice the difference between these two triangles. The one on the left is going to be pretty easy for you to find C. You've done it a million times. You would have used the Pythagorean theorem. A squared plus B squared equals C squared. No problem. You can do that and find that hypotenuse right there. But what happens when it's not a right angle? You can't use the Pythagorean theorem. And that's where the law of sines is going to come in. Law of sines looks something like this. And so you can see the formula is going to look a little bit more complicated. Once you get the hang of it, it's not that bad, but it's definitely different than the Pythagorean theorem. You can't use the Pythagorean theorem if you don't have a right triangle. So make sure you get that straight. It's going to be important for you to remember some things that you might have learned in geometry class. How to prove triangles congruent by angle, angle, side, angle, side, angle, side, angle, side, 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 side. All of that should come back to you. You should remember that, as well as the bad case. All right, there was one problem in geometry that your teacher said you cannot do, you cannot prove triangles congruent, and they might have spelled it backwards and said, just remember it's a bad word. We're going to be able to do that this time. We're not proving triangles congruent, we're trying to do something else, but the bad one is just going to be a little bit harder to deal with. So it's going to be really important that you can distinguish between angle, angle, side, angle, side, angle, side, side, angle, side, angle, because it's going to tell you which formula to use. Law of sines, I already showed you the formula for. Law of cosines will come a little bit later. So a few years back, there was a app. It's called Temple Run. It was a very popular game, and this guy was running through this temple, through this jungle, and the object of the game was for this guy to collect all these coins. Maybe you've played it, maybe you remember it. It was called Temple Run. I want you to think about that concept as you try to identify what type of problem you're looking at. You're going to see a triangle, and it's going to have some different things marked or some different pieces of information given. And I want you to imagine that you're this runner running around the triangle. So remember, the object of the game is to collect these tokens. All right, so if you can visualize that, you can see that this is an angle, and this is a side, and this is an angle. And so hopefully you can recognize that this problem is going to be an angle, side, angle problem. That's going to tell you how to proceed, which formula to use, what to do, and that kind of thing. Now you got to pay attention, and you don't want to go the wrong way. If I started here at an angle and then run, I don't want to go that way. I don't want to go that way because I'm going too long without picking up one of my tokens, one of my coins. And so sometimes people that don't quite understand will say, well, here's an angle, and then here's an angle and a side. They'll get the wrong case. All right, so keep in mind you're trying to grab these things as quickly as possible. So angle, side, angle. Here's another example. I see an angle, angle, side. Angle, angle, side. So this is an AAS problem. Angle, angle, side. Here's another one where I would go, this is a side B, angle C, side A. This looks like side, angle, side. Here's one. And it doesn't really matter where you start as long as you pick them up quickly. So if I start here, that's angle, side, side. Ooh, that's the bad one, right? Okay, you're not supposed to say the bad word, but I think it's easier to remember that that's the hard one. That's the bad one. It's not that we can't do the problem. It's just going to be more complicated. Or if you go around this way, side, side, angle. Some teachers are going to force you to write that because it's not a bad word, but it's the same thing. Whether you do angle, side, side, or side, side, angle, it's the same thing. It's going to be that case too, which is called the ambiguous case. It's the hard one. There's extra things you have to think about. So forget about tokens for a second. You're going to see numbers. You're going to see angles and sides, but it's just the same thing. Angle, side, angle. and this one would be, that's a side, angle, side. Okay, so the last thing I want to do here is I want to demonstrate why SSA is bad. It's called the ambiguous case. Okay, ambiguous means unclear. So if you have those three pieces of information, a side, side, and an angle, it might be unclear if you have a triangle at all. And so here you can see I've drawn a triangle, and I tried to mark in red the pieces that were given. So let's say we know this angle A, and we know this side B, and this side A of a triangle. Here's why this is ambiguous. If I have an angle here, and a side here, and a side here, notice what happens if I rotate this around. I've got the same three pieces of information, an angle A, a side B, and a side A. I've still got those same three pieces of information, but I've got a completely different triangle. So that's why this is ambiguous. It's unclear whether we have this triangle or this triangle, or sometimes it might not even form a triangle at all. So you've got to be really careful with the ambiguous case and look for that. Good luck.